Hello, everyone. Nice to meet you. And this is a data structure class. Welcome to my class this semester. And last class, we have studied what is computers. So we have seen many various research fields in computer engineering department. Among them, we found that data structure is most important part in computer engineering. Especially, we are very interested in the program development. During program development, algorithm and the data structure is most critical part. So we are going to learn data structures. Okay, so today we will start chapter 1, first chapter in our textbook. So the title is Basic Concept. Okay, so this chapter will introduce the fundamental uh, concept or terminologies used in the through the class. Okay, so let's start. Okay, as we seen last class about computer system, so we have seen that program development is most important. Okay, so the program can be created following some system life cycles. Okay, so we can say that this is a system life cycles. Okay, so there are some steps or phases to develop or to create programs. Okay, so our goal is develop programs. So in order to develop program, we must follow the phases. In this slide, there are 5 phases. Okay, it starts with requirement. Okay, so we must collect some user requirement for the program. So that is a first step. Okay, collecting the requirement, we must analyze the requirement to move to the design phases. Okay, so the analysis approaches can be divided into 2 approaches. So one is a bottom up. Okay, it starts from the bottom to the up. Okay, the other contrary one is a top down approaches. Okay, uh, both approaches can be used to analyze the requirement. Okay, and design can be said that we can use object oriented design. Okay, so that means that we must design uh, what is a data object and what is operation that can be applied to the data object. Okay, that is design phases. Okay, using this design, we will implement that design using codings. Okay, so coding means that we implement the design using computer languages like C languages. Okay, there must be some errors, so we must refine the codings. So we must coding and refine it repetitively. Okay, several times. So that is fourth steps, refinement and codings. Okay, and last step is that verifications. Once it is developed, implemented, then we must prove the program that the program works well. And also we must test the result. And also if there is logical errors, then we must debug the programs. Okay, so that is the last steps of the program development. In here, what is the where is the data structures located? Okay, so in here, during the 5 steps, the third step, design, this phase is most important in the whole life cycles. So here, design means that it is data structures. Okay, so data structure is for data object, and operation is for algorithms. Okay, so this third steps, design steps, include data structure and algorithms. Okay, so our class data structure will be located in the design phase. Okay, so I think that this design phase is the most important during whole the life cycles. Do you agree? Yes. Okay, then what is the data structures? What is data structures? So in program, we must handle data. So how data are stored and organized, and then that stored data can be handled or operated. Okay, for example, so array is most powerful, most basic data structures to store some data. Do you agree? Do you remember that C language class in freshman? Yes. Array can hold the data, of course. So we can store some integers into array. And this array itself is already structured. Okay, structured means that they can be handled systematically. Okay, that means that we can store the data into array with index, and also we can access the data using array index. Okay, so we can retrieve the stored element. Okay, so this array itself is a very excellent data structures itself. Okay, because array can store, can hold data, and array itself is already structured. Okay, so array is typical data structures. And if then, what is algorithms? Algorithms. So algorithms definitions is that task to be performed efficiently, then we need some algorithms. So algorithms, as I said in the last class, definitions of algorithm is the problem solving procedure. Okay, so that can be algorithm can be said that problem solving solving procedure. And also the exact definition of algorithm is defined in our textbooks. Okay, so in textbook page um, page 8, 8, oh, 8. In page 8, there is exact definition of algorithms. So you can refer to the algorithm definition in page 8 of our textbook, but we can understand that algorithm can be said that problem solving procedures. Okay, so this algorithm must depend on the data structures because algorithm must use store the data in data structure. If the data structure is designed poor, then it is the algorithm must be inefficient. Okay, so in order to make algorithm efficiently, then we must design data structure also soundly. Okay, so good data structure will make good algorithms. Okay, so they are very reciprocal between algorithm and data structures. So example of data structure and algorithms. First example is here. So I want to build database of student, okay, of our university JBNU. Then usually the number of students per year is 20,000 students. But year by year, the data size will increase because new students incoming and graduate students are going. So the number of students will grow in size every year. Okay, but I want to store all the data of students into our data structures. Okay, then what kind of operations necessary? So we must search some student data from the stored data and retrieve. Also, new students can be inserted into the data set. So in order to implement this database, we can use array. Yes, array is very excellent data structures. Okay, so in order to insert new student, we can simply add it to first empty array cell. Okay, but if the current array is full, okay, no empty cell, then we can create new array. The size is double of the current. And then we copy all the original full old array to new arrays. Okay, so usually array is a very excellent data structure to store this example student database, but this problem, if current array is full, then it takes a very long time to create new double size array and copy all the data to the new uh, arrays. Okay, so there is some uh, defect of the array data structure in this example also. So we can find some advantage and disadvantage of array data structure in this example. In other words, uh, student database can uh, use array, but there can be advantage and also disadvantage can exist. And also, in order to search for a student in the database, we must look at all entries in the array one by one. Sequential search is necessary. Okay, is it efficient or not? I think a sequential search is not so efficient. Okay, so array looks like a very good, excellent data structure for the university student database, but we can find some defect of the array data structure for these examples. Okay, so the defect can be found when the current array is full and such array also may make some defect. Okay, so we can say that your programming experience, however, tells that this is not a good method. Yes, a regular array is not so good data structures for the university students data set. Okay, and in chapter 10, there may be some another data structures, and in the next future chapters, we will learn the other data structure types other than array. Then we can find better data structure in the future chapters. Okay, so that means that fast algorithm is possible if we adopt better data structure design. Okay, that's our goal of this class. We try to find better data structure design for our some specific goals. In this example, student data is our goal. So in order to implement student database, we can use array, but there may be some defect. So we can improve the data structure design using the following future chapter data structure types. Okay, and the second example is that polynomials. Yes, this is a polynomial. Polynomial means that one functions that has many terms, multiple terms. That is polynomials. Okay, then how we can store or define these polynomial functions in data structures. Okay, so we can also use array to store the coefficient. This is a coefficient. In each term, there is coefficient. So we store every coefficient of each terms. Then we can define one polynomials. Okay, so in this example, the data set is coefficient data set. Okay, and data structure is array, the same as first examples. Okay, and then but another alternative data structure is linked list instead of array. Okay, so in using linked list, then instead of storing every coefficient into array, we will store only coefficient and the exponent of each term into one node in the linked list. Like, for example, 3x squared plus 5 is one polynomial. This is one polynomial. In order to store this polynomial, we can store using linked list. This is one node. This is another node. These two nodes are linked by this arrow. Okay, so this is a new alternative data structures called linked list data structures. Okay, so here to represent the polynomials, both data structures. What is both data structures? So first one is array, to store every coefficient of the polynomial, and the second one is linked list. Okay, so both data structure have their relative advantage and drawbacks in the time and space considerations. Okay, so we can find some alternative of data structures for specific problems. In this example, the problem is polynomial data. So polynomial data can be stored in array and linked list. Each data structure has advantage and disadvantages. So we must consider some criteria to determine which design is a better one. First one or second one, array or linked list. Okay, we must decide the better data structure design, array or linked list. Okay, so the criteria to make a decision used in here is time and space considerations. So time and space considerations. Okay, so we will learn what is the time complexity and the space complexities. So we will only study time complexity, okay, later on. And okay, so that's the data structure designs. So determining which better data structure design is very important in our class. Okay, now we will show what is array data structures in searching algorithms. Okay, so in searching algorithms, we can use regular arrays to store data. Okay, so using regular array, we will search sequentially. Okay, so that means that sequential means that it will search from the first data one by one, proceed one by one, and until last data. That is a sequential search. But if the data is sorted and then stored in the array, then it will be searched much faster using binary search method. Okay, so sequential search is one algorithms one, but another algorithm is binary search is algorithm 2. So which algorithm is better algorithms or efficient algorithms? So that means that which algorithm executed faster? Of course, binary search is much more faster than sequential search. Okay, so in order to implement binary search, but we must store data sorted. Okay, sorted. That's the difference. So the sorted array is not the same data structure as general array. Okay, can you understand this one? So in order to implement much more efficient algorithms, you must adopt better data structures. Okay, so in this case, algorithm 1 will use regular or general array. But binary search will use sorted array. Okay, so quite different data structures. Okay, so we can understand that every algorithm will depend on the data structures. Okay, so in order to develop one excellent program, we must design data structure efficiently to execute algorithm also efficiently. Okay, so both algorithm and data structure are tightly correlated or tightly coupled. Okay, we cannot think separately algorithm or data structure. We must think together with algorithm and data structure simultaneously. Okay. So this is a explanation about binary search. Okay, so this is data set is stored in array. This list is array. Index is from 0 to n minus 1. So that means that this array will store n size of data. Okay, so I want to search some data set, some number, search num from this list array. Okay, that is a search problems, and this list array is sorted. For example, it is if it is ascending order sorted, and every data are distinct, then you can say that list 0 index is a small list, and list 1 is larger than list 0. In this way, list n minus 1 is a last data set, is a largest one. Okay, and we can say that n may be 5. There are 5 data sets in this example. Then we can say that if such number is larger than middle data list index 2, then such number must be located between third and fourth list index. Okay, it cannot be located in the index 1 and 0 because data set is sorted already, and such num is larger than list 2. So that means that the searching number must be located in index 3 or 4. Okay. Uh, on the contrary, such num is less than list index 2, then such num must located between index 0 and index 1. Okay, so left side. Okay, so this is a example. So I want to search 11 from the array. List is 3, 5, 7, 11, 13. Yes, there are 5 number of data stored in the list array. And we can see that this 11 is located here. Okay, at first time, we will start the middle data. In this 5 data, medium data is 7. Okay, we will compare such num 11 and the middle number 7. Okay, 11 is larger than, greater than 7. So we can see that 11 cannot be located between this index 0 and the index 1. It must located at this right side. Okay? Okay, so that is binary search method. Okay, so now another example is here. So if we try to search number 17 from this data set. So the total number of data is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes. Okay, so left number is 0, index is 0, and the right index is 7. Okay, we will find middle index. So 0 plus 2 divided by 2 can be rounded as 3. Okay, so 3 index 0, 1, 2, 3. Yes, this number can be said that it is a middle data among the whole data set. Okay, so we will compare with list middle with it is a 7, and such num is 17. Okay, 17 is larger, greater than 7. So we will move left index as middle plus 1. In other words, middle was 3, so plus 1 means that 4. Okay, so that means that we will try to find such num among the right side of the data set. Okay, we will discard the left side of this one. So, okay, because 17 will be located only the right side. Okay, that is a binary search concept. Okay, now left is 11 and the right is 19. So left value is 0, 1, 2, 3, 4. Yes, 4 index. And this is 7. Okay, so now new middle number can be calculated by adding 4 plus 7 divided by 2 equals 5. Okay, and list 5 means that this is 5. So the value is 13. And we will compare such num and middle values 13. Still, such num is greater than middle values 13. Okay, so also we will adjust left value. Also middle plus 1 becomes 6. Okay, this one is 6 index. Okay, now middle left is 6 and the right is 7. So new middle number becomes 6 plus 7 divided by 2 equals 6. Okay, least middle value becomes 17 and such num is also 17. Okay, so such num and the least middle values are the same. That means that we can return middle values at this case is 6, and that is our desired position, and searching is done. Okay, so 17 was located at index 6. Okay, so mission completed. Okay, so that is binary search. I think this is much more efficient than sequential search. Sequential search means that it will start from the first, compare with such num. Okay, 2 and 17, no, not the same. And going to the next element. 3, compare with 3 and 17, no. And in this way, we will proceed one by one to the right. So that is sequential search method. Can you find how many steps are used to find the solutions? Okay, so I think the previous slide there was one steps, and this is a second step, and this is a third step. So only 3 steps are used to find these numbers 6. Okay, if you use sequential search method, we must compare 1, 2, 3, 4, 5, 6, 7. Okay, so sequential search method need 7 steps to complete the mission, but this binary search need 3 steps to complete the mission, searching missions. Okay, so which one is more efficient, more fast? So I think binary search is much more fast than sequential search. Okay, the binary search implementation is in program 1.7 in our textbook. So this one, binary search input is a list data set, and the search num is our goal number, and left and right is index. Okay, so middle index will be calculated by using left plus right divided by 2. Okay, and compare such num and list the middle values. Okay, so such num is smaller than list the middle number, then the such num is located on the left. So that means that we just adjust right values as middle minus 1. And if such num and the list middle values are the same, then mission completed. So we just return the middle values. And otherwise, left value must be adjusted to search on the right side of the data set. Okay, so left value will be adjusted as middle plus 1. Okay, we will search only right side of the middle. Okay, so that's binary search algorithms. This is algorithms. What is the data structure used in these algorithms? Can you answer it? So data structure used in this algorithm is that this list array. Okay, so this list array, of course, is sorted array. Sorted array. Okay, so in order to execute binary search, we must given sorted array as data structures. Okay, so that's binary search, and let's go on. And we can also improve this binary search using recursive functions. Okay, do you remember what is a recursive functions? Yes, the function itself is called directly or indirectly. That is called recursive function. Okay, the typical example of a recursive function is Fibonacci sequence and the binomial coefficient, and the summation is also recursive functions. But in our case, binary search can be implemented using recursive functions. Okay, so the same logics can be implemented using this one. Yes, the same. Inside the definition of a binary search is used, but the parameter is slightly different. This parameter is left and right, but this parameter is left and the middle minus 1. And this binary search also uses different parameters. Okay, instead of a left, they will use middle plus 1. So this means that right part will be searched, and this means that left part of the data will be searched. Okay, so that's the same logics as binary search. Okay. Okay, this is one example implementation of selection sort program. This is one program, complete one programs. But I want to execute. I want to compile this program and execute one. Okay, and if you look into this program, main will start point here and print scan data, and it will call to sort here. The sort function is implemented here, and it will make a result. So that means selection sort. Sort means that it will sort the data. So the given data is not sorted yet, but after this program, the data will be sorted. Okay, so this program, one complete program, consists of data structure and algorithms. So can you answer that what is the data structure used in this program, and what is algorithm used in this program? Okay, think about it and answer about it. Okay, so data structure must store the data used in this program, and algorithm is problem solving procedures. So in here, the problem is sorting. So the sort in here is sort function is one algorithms used in this program. And what is the data structures? Okay, so you must look where the data is stored. Okay, so in this program, all the data will be stored in num_array dataset here. Okay, so the data structure used in this program is num_array. This array size also can be specified as maximum size is here 1000 or 10,001. Okay, so this is a data structure defined in this program, and algorithm can be said that sort function. So the function is this parenthesis here, not angular bracket. Okay, so we will we will compile this program and execute by yourself. Okay, that is your homework. Okay, let's go on. Okay, let's stop here for the part 1 of chapter 1, first chapters. Okay, we will continue part 2 from this data abstractions. Okay, thank you.